Hi 34 students. This is Module 4 Example 3 starting on page 90. So Example 3 compares 4 different models for the relationship between backpack weight and a percentage of body weight. So take a minute and pause the video and read through the text of Example 3 if you haven't yet. And then you'll see there are A, B, C, and D, 4 different predictions. And the data in the blue dots is the same for all 4 graphs, and the differences are the 4 lines. Now on graph B, I think only the bold line is supposed to be there, so the second line that's in there is a typo that we should have deleted out. B is the flat line, and here with positive slope. So starting on page 91, we're going to analyze the different tables and different ways we can look at these best fit lines. What we're trying to figure out is what of the 4 lines is actually the very best fit. So we're going to look at some different methods for determining that. So here in table A, you can see they have the X and the Y values that correspond with the graph of the scatter plot. And then they have columns for each of the lines, and they give the predictions. So remember, line Y or column Y is the observed or the actual value, and then each one of these columns corresponds with a different prediction. So we need to use the equation to fill in the predictions for each one of these missing spots in the table. So you can go back to the equations that are on page 90 and use those to calculate. So if you want to take a minute and pause and calculate, then you can come back and work this out and check your answers with my answers. Okay, so I'm typing in the data values and I'm working to get them to fit in my data spots. Okay, so I think I got everything to fit in there. So you can check these calculations that I made using the regression equations with your calculations from the equations on page 90. And now we're going to do the same thing for the body weight of 82 down here at the bottom of the table. And you'll notice that the last column is always 19.5 because that's our steady line. Okay, so take a minute and check to make sure that your calculations agree with my calculations here. Question B is asking, now which of the 4 lines do you think results in the best overall prediction of backpack weight? Why and how are you selecting the best fit line? So judging from the graph and the table, lines B and C seem to be the closest fit to the observed data. If we had to choose between lines B and C, line B seems to be the most accurate. And again, we are using what we call the eyeball fit to make this decision. So we're going to look in this example at a better way to make a more accurate decision besides just using the eyeball fit for our best estimation. So let's go ahead to page 92 and look at the table and scatter plot here. So now for each model, A, B, C, and D, we're going to complete the table, so there's some missing spots in the table, and then follow these directions to circle in the scatter plot. So you can see the table has now calculated out the error, otherwise known as a residual, which is the observed value subtract the prediction. So we've got a couple lines to fill in here. So for body weight 62, the actual or observed data backpack weight is 18 and the prediction is 7.9723. So if we go ahead and subtract the observed data minus the prediction, we get 10.0277. And then down here for the last entry, a body weight of 119, if we subtract the backpack weight minus the prediction, we get negative 13.5874. And again, you can verify these on your graphing calculators and check these calculations. So now we want to first circle the student for who the line comes closest to predicting backpack weight. And so if we look over at our error, that's the student with the least error. So as we go through the errors, it looks like the student who had the body weight of 59 had the smallest error for this data. And we can see that right here on the graph, right next to the 60 mark. It looks like the line for regression is going right through that point. Now the student who has the actual backpack weight furthest from the prediction appears to be close to 70 on the graph. And if we look down here, we see the student who had the body weight of 68 is that point, and that is in fact our furthest error. So let's go ahead and circle that value also. So now we're going to go through the same process for lines B, C, and D. So here on page 93 we have line B. And again, we're going to calculate the error, otherwise known as a residual. So we take the observed value and subtract the predicted value. In this case, we get a negative because the observed value is smaller than the prediction. And again, use your calculator to check my calculations. And then our error here is, for the body weight of 72, is negative 9.564, down lower in the table. Now again, we want to circle the student who has the line that comes the closest to predicting the backpack weight. And remember, this is the graph with the extra line in there, so we're going to refer to the bold line. So the closest looks to be the student who is at 54. So I think that's right around here on the graph. It's hard to tell. And then the furthest is, judging from our residuals, the student who is at the body weight of 68. So that's up high on the graph. Okay, and I'm going to adjust my circle. Good. And now we can go down and go to page 94 and look at line C. Okay, so this is line C on page 94, and we're going to start by filling in the table. So we see for body weight 59, we have to calculate the error or the residual there. And so if we subtract the observed value minus the predicted value, we get here negative 9.3896. And then down for the body weight of 76, if we subtract the actual or observed value minus the predicted value, we get 2.21. And then we want to go ahead over to the graph, and we're going to circle the student for who the line comes closest. So looking at our data, it looks like that is at 54. That has the least error or least residual. And then we want to circle the student for which the actual backpack weight is furthest from the prediction. So once again, that's our outlier up here with the body weight of 68. Okay, let's go ahead and do the same thing for line D. So now we're on page 95, and we're going to start by filling in the table here. And so for the body weight of 62, we subtract our observed value minus the prediction, 18 minus 19.5 gives us an error or residual of negative 1.5. And then also we're missing the data for the body weight of 104. So 26 minus 19.5 gives us an error or residual of positive 6.5 here. Now we want to come over to the graph and circle the student with the closest prediction. So if we look at our residual list, that appears to be the student with the body weight of 95. And if we look at the graph, that one goes right through the line. Notice how they had the lowest error of 0.5. Now the highest error is a tie between positive 12.5 and negative 12.5. So positive 12.5 is our outlier at 68. And then down here at negative 12.65, there are two outliers down there. So you could circle either of those because they're both equally far away. They're both 12.5 percentage units away. So now we're going to use these error calculations to determine which graph is actually the best fit. So to fill in this table in part D, you have to sum up all the errors for the different lines. So it's going to take a while. And you can use your graphing calculator or you could copy it into Excel and use Excel calculations to do that. So if we sum up the errors for line A, that gives us 77.5994. So you could go ahead and do these calculations and then come back and check your calculations against mine using either your graphing calculator or Excel. The first column is sum of the errors. The second column is the sum of the absolute values of the errors. So you're going to have to take out all the negatives when you sum this up. And then the third column is the sum of the squares of the errors. So you're going to have to square each one of those errors, which will make them positive, and then total it up. So again, you can go through these calculations on your graphing calculator or in Excel, and then check your calculations with mine. You can see if I made any errors. And again, I'm rounding to 4 decimal places. If we don't say otherwise, go ahead and rule of thumb round to 4 decimal places in our class. Okay, now if we go ahead and look at the different ways to calculate best fit in terms of error, we want to look for the line that has the least error. So for sum of errors, line B has the least error. And then if we look at for the sum of the absolute value of errors, the SAE, also line B has the least error there. So let's go back and put in our SE for sum of errors. Sum of absolute value of errors is known as SAE. Maybe we should put an S of E. SE usually stands for the standard error, so I didn't want you to confuse that. And then the last column, sum of squares of errors, is the SSE. Right, and there line B also has the least error, although line C is not too far away. So overall, we think that line B provides the best fit. So there's a note about why statisticians square the errors. So you can see that that minimizes the sum when compared to all the other possible lines. Now, example 4 gives this formula for the correlation value R, which you've seen in the OLI software. And we want to talk about why the correlation value R is a good indicator for how well the graph fits. If you look at the formula, we're subtracting right in here. This is the observed minus the predicted value. So we can say the correlation formula subtracts the observed and predicted values for the x and y coordinates on the graph. And then the correlation sums up all these differences in their products. So the correlation formula sums up all the difference products, we call them, because see how there's some multiplication going on in there, for x and y values. And then finally, the correlation formula divides by n minus 1, which is 1 less than the number of data points. Okay, and we won't go into depth to why they use n minus 1 instead of n. The reason they do that is it smooths the fit a little bit, and statisticians found that this gave a better overall prediction by subtracting 1 from the number of data points. Okay, go ahead and work on the group assignment, and remember to comment in the discussion forum.